Hello everyone. In this video, we will solve some numerical problem on work done. As per the given question, electric field vector is given. We are asked to find the differential amount of work done in moving the charge of 6 nanocoulomb through a distance of 2 micrometer, where the starting point P has the coordinates 2, -2, 3, and the corresponding direction in which the charge is moved, AL cap, is given. There are 3 subdivisions given. We will do the subdivisions one after the other. First, let us start with the work done formula. Differential amount of work done, dW, can be given as this. Differential amount of work done, dW, can be written as minus Q E vector dot dl vector. This is the formula. We have to write whatever is the given data. Charge Q is given as 6 nanocoulomb. We know nano is 10 power minus 9. And E vector is also given. The vector E is given as 1 by z square, 8xyz ax cap, plus 4x square z ay cap, minus 4x square y a z cap volt per meter. This is the vector E given, and the distance L is given as 2 micrometer, or I can say DL is given as 2 micrometer. We can write micro as 10 power minus 6. Then AL cap is given. How to write DL vector now from this AL cap? This DL vector should be written as the magnitude DL multiplied with AL. That gives the vector DL. So I should write DL vector as DL magnitude multiplied with AL cap. So for each of the subdivision, we have to multiply this magnitude and the corresponding given direction vector. So that is how we will be solving this numerical problem to find the work done. So let me write this dW as minus Q E vector dot DL magnitude into AL cap, or we will be writing minus Q DL magnitude E vector dot AL cap vector. So this dot product between given vector E and the AL vector should be done, and the corresponding values should be multiplied. So this is the given E vector and AL vector. For subdivision 1, AL vector, AL cap is given as minus 6 by 7 AX cap plus 3 by 7 AY cap plus 2 by 7 AZ cap. So we are asked to find this dW at the corresponding point P. So for XYZ, you have to take the value as given in the point. In this electric field intensity vector, we have to take X value is 2, Y value is minus 2, and Z value is 3. This is corresponding to the given point 2, minus 2, 3. So you have to substitute it and take dot product to get the differential amount of work done. So let us do that. The differential amount of work done, dW, can be given as minus Q. Charge is 6 nano, 6 into 10 power minus 9, and the magnitude of length is 2 micro, then multiplied with E vector dot AL cap. So this we have to write, which is 1 by Z square, which is 1 by 9, and I will be writing 8xyz. So 8 into 2 into minus 2 into 3 AX cap plus 4 into 2 square into 3 AY cap minus 4 into 2 square into minus 2 AZ cap. This has to be taken dot product with minus 6 by 7 AX cap plus 3 by 7 AY cap plus 2 by 7 AZ cap. So now when we are taking dot product, this X component value and this X component value should be multiplied. This Y component value and this Y component value should be multiplied. This Z component value and this Z component value should be multiplied to get the dot product between two vectors. You can recall how we have taken the dot product between two vectors. So we can compute that. So minus 6 into 10 power minus 9 into 2 into 10 power minus 6. And 1 by 9 is common. I can write this 1 by 9. And we can take here 1 by 7 common from all these terms. So I'm writing 1 by 7 also common. Then multiplied with, I can write this 8 into 2 into minus 2 into 3. This has to be multiplied with minus 6 by 7. So this is the multiplication of x component plus multiplication with y component, that is 4 into 2 square is 4 into 3. This has to be multiplied with 3. So since 1 by 7 is already taken outside, I have to write only 6. And for the third term, which is minus 4 into minus 2 multiplied with 2. So when you do the computation of all these things, you will be getting minus 149.33 into 10 power minus 15 joules. This is the differential amount of work done for subdivision A. Now, we should know how to write this 10 power minus 5. This power of 10 power minus 5 is called as femto. So this 10 power minus 15, sorry, not 5, 10 power minus 15 is called femto. Thereby, we can write the differential amount of work done as minus 149.33 femtojoules. So this is the answer for first subdivision. In a similar way, we have to just change this AL cap. This AL cap should be changed for the second subdivision and perform the similar calculations. You will get the work done for the second subdivision and third subdivision. I will do that and show for you. Now, continuing to proceed with the second subdivision, when you look at the AL cap for the second subdivision, that is 6 by 7 AX cap minus 3 by 7 AY cap minus 2 by 7 AZ cap. So it is just the negative of the first subdivision. When you see the first subdivision and the second subdivision, it is just the negative sign. So whatever work done we are getting, one negative sign will come. Instead of computing again, I'm writing directly, it is going to be plus 149.33 femtojoules. You can do it again and verify whether you're getting the same answer. Since the AL vectors are negative of each other, one negative sign is introduced. So the final answer will be the same with one negative sign introduced, which gives plus 149.33 femtojoules. Now let us do the third subdivision to find what is the answer. So let us do the third subdivision, which is a different AL cap. So for third subdivision, AL cap is just 3 by 7 AX cap plus 6 by 7 AY cap. Now we have to write dW, which is minus Q E vector dot DL vector, or you can write minus Q DL magnitude into E vector dot AL cap. I'm writing directly from the previous step. So I have to multiply this value. Q is minus 6 nano and the length DL is 2 micro. Then vector E has to be taken dot product. So 1 by Z square. So I have to write 1 by Z square as 1 by 9 into 8 XYZ, that is 2 into minus 2 into 3 AX cap. Then the second one is 4 into 2 square into 3 AY cap. Then the last component is 4 into 2 square into 2. I think it is minus 2. Oh, sorry, it is correct. So minus of minus of minus 2 AZ cap. This has to be taken dot product with AL cap, which is 1 by 7 I'm taking common, 3 AX cap plus 6 AY cap. So let us proceed further to find what is dW. Minus 6 into 2 into 10 bar minus 15 I'll be writing. Then 1 by 9 and 1 by 7 I'm taking common. And multiplying this is going to result in, I will be writing this, only x component and x component should be multiplied. This x component and x component should be multiplied. Y component and y component should be multiplied. Since there is no z component, 0 AZ cap, this 0 and 0 multiplication will result in 0 there. So we will be getting 8 into 2 into minus 2 into 3 multiplied with 3. And the second term is 4 into 4 into 3 into 6. So when you do this, we will be getting the answer to be 0. So what you will be getting, I will write here shortly. 16 into 3 into 6. So similarly here also 16 into 3 into 6. So this is minus, this is plus. That is going to give 0. So the total work done in this case is becoming dW is equal to 0 joules. So the net work done for the second direction is 0 femtojoules also you can write, because the power is 10 power minus 15. I have wrongly written as 12. This is 10 power minus 15 femtojoules. So this is how we should proceed for this type of example problem. We will solve more numerical problems in further videos. Thank you for watching the video.